So in today's class, we want to explain integration. Now, before you can understand integration, I have to take you back to differentiation. In differentiation, you are dealing with y is equal to f of x. If y is equal to f of x, then the derivative of y with respect to x is equal to dy dx, which gives f prime of x. Now, this is differentiation. So, for example, if I have y to be equal to x, then my dy dx, that is the derivative of this y with respect to x, is equal to dy dx is equal to x raised power, this is x raised power 1. So the power of this x, you use it to multiply x, then you subtract 1 from it. So dy dx is equal to x raised to the power of 0. And anything raised to the power of 0 is equal to 1. So if you are yet to understand all this thing, I have video on it so you can watch it. From here that I have dy dx to be equal to 1. You know, it's y is equal to x was the initial function that I had. So I can now say that y is equal to what? X plus z. So this is the antiderivative. This is the derivative with respect to x. So that is how to do it. Also, if I have y to be equal to x squared, you know, I can say dy dx is equal to what? 2x. Now, this y is the antiderivative of dy dx. So this is antiderivative. And this one is the derivative. So the inverse of differentiation is known as antiderivative. And this antiderivative is what we know as integration. So from here, I said that y is equal to x squared. So if I want to write it indefinite integral, I have to put plus c there. So that is the constant. So for example, if I have y is equal to x squared plus 5 or anything, you know, if I differentiate it with respect to x, I get what? 2x. This one is the general solution. General solution. And here is the particular solution. Why? Because the general solution is when I did not have the value for my c. And the particular means when I have value for that c. So in a nutshell, I can say that if I have my dy dx to be equal to x raised to the power of n, then the antiderivative, I can have y to be equal to x, then the power, which is n, plus 1 divided by n plus 1, then plus constants. This one is the general solution. General solution. And here is the particular solution. Why? Because the general solution is when I did not have the value for my c. And the particular means when I have value for that c. So in a nutshell, I can say that if I have my dx to be equal to x raised to the power of n, then the antiderivative, I can have y to be equal to x, then the power, which is n, plus 1 divided by n plus 1, then plus constants. So in a nutshell, I can say that the process of going from derivative to antiderivative is known as integration. So the process of integration is the reverse of the process of differentiation. You have to know that. So if I have dx to be equal to x raised to power n, the process of integration has one sign, which is like this. This is integral sign. Now, if I want to integrate this equation now, it will be y is equal to the integral of x raised to power n. So y will not be equal to, if I integrate this one, I said earlier that it becomes x raised to the power of n plus 1 divided by n plus 1 plus c. But it has condition. The condition is that n must not be equal to minus 1. That is the condition for integration. Your n, that is the exponents, must not be equal to minus 1. The integral of f of x with respect to x, this sign, this symbol means indefinite integral. That is, it doesn't have limits. It doesn't have limits. So I do not have limit for my x. So you understand what I'm saying in future. Standard integral forms. So if I have the integral of x dx, so the integration of this one will give me x, the power of x here is 1. So that power then plus 1 divided by the whole of the new exponent now, which is 1 plus 1. So divided by 1 plus 1, then plus c. For indefinite integral, plus c is very, very vital, very, very important. Don't forget it. Now, the integral of x dx is the same thing as x raised to the power of 2, then divided by 2, then plus c. So let's call this one number 1. Another one, let's say I have the integral of x squared dx. We are integrating it with respect to x. So I'll now have, you write this x, you write the exponent, which is 2. Then you add 1 to it. Then this is the new exponent. You take all the new exponents, which is 2 plus 1, you divide by the whole expression. Then you add c to it. So the integral of x squared dx is equal to x cubed divided by 3, then plus c. So that's that. Now the integral of constants. Let's say we want to integrate constants. Take any alphabet or any number without x. So you want to integrate it. If you could remember, if you want to differentiate constants, the answer will give you 0. But we say that integration is the inverse of differentiation. That means if you want to integrate constants, you have x beside it, then plus c. So to integrate c with x, so the answer will be equal to c x then plus c. Another example on integration of constants. Number 4. So let's say I have integral of 5 dx. So the answer will be 5, then multiply by x, then plus c. So if you integrate constants, you have x beside it, then plus c. The number that you want to integrate with that, which was without x. So if you integrate it, it becomes that number or that alphabet or that constant multiplied by x then plus c, like I did here. So let's say I want to integrate x raised to the power of 5 divided by 2 dx. You know, when I was explaining, I told you that your n must not be equal to minus 1. Aside minus 1, your n can be any other number. Be it minus 5, minus 6, minus anything, and any positive number. So it means that our n must not be equal to minus 1 alone. So it could be negative fraction. Your n can be fraction, 1 over 2, 3 over 2, anything. Then could be minus 5, minus 6, and so on. Any positive number, any negative number, except minus 1. So back to what we are integrating. So the solution will be x raised to the power of that minus 5, you write it, then plus 1. Then this is your new exponent. This new exponent, you use it to divide everything, the expression. So we have x raised to the power of minus 5 plus 1 gives me minus 4. So raised to the power of minus 4 divided by minus 4. But don't forget that I have this 1 over 2 there before. So I write it. So I have 1 over 2, or just say 2 multiplied by this one. So 2 multiplied by this one. So my answer is equal to x raised to the power of minus 4 divided by minus 8. So that is how to integrate any integral in form of this. Number 6. If I want to integrate x raised to the power n dx, that is, it has coefficients. So like this one, my answer will be a, then x raised to the power n plus 1 just over n plus 1, then everything plus c. d dx of sine x, that is differentiation of sine x, is equal to cos x. Integration as the inverse of differentiation now. You now say that the integral of cos x dx is equal to sine x. So this is number 7. Number 8. d dx of cos x gives minus sine x. So you can now say that the integral of minus sine x gives me cos x. So invariably, I can say that the integral of sine x, then you put plus c. Don't forget to put plus c. So then the x here. So the integral of sine x will be equal to minus cos x then plus c. So that is it. Now number 9. The differentiation of tan x is equal to what? Sec squared x. So the integral of sec squared x dx is equal to what? Tan x plus c. Also, the differentiation of sec x gives us sec x tan x. So if you now want to integrate sec x tan x dx, the answer is equal to sec x plus c. The differentiation of cosec x gives minus cosec x cot x. So the integral of minus cosec x cot x dx is equal to cosec x. So you can see that the integral of cosec x cot x dx is equal to minus cosec x. Also, we have differentiation of cot x is equal to minus cosec squared x then plus c. Forget plus c. Plus c. So the integral of minus cosec squared x dx is equal to cot x. So invariably you can say that the integral of cosec squared x dx is equal to minus cot x plus c. You can see. Then what else again? The differentiation of exponential x. Then we can put plus c there, that is if it has any constant beside it, is equal to exponential x. Then the differentiation of exponential x plus c is the same thing as exponential x. Now, the integral of exponential x dx is the same thing as exponential x plus c. So, now, the integral of 1 over x dx. You know, I told you that your n must not be equal to minus 1. If you write this one out, it gives us x raised to the power minus 1 dx. But in integration, our n must not be equal to minus 1. So you don't express it like this. Don't do it that way. So you just say that the integral of 1 over x dx is equal to ln x plus c. So here is the summary of what I've been saying since, so you can go through it. Now, for example, if we have the integral of x cubed minus 3x squared plus 2x plus 5 dx divided by x, we want to find the integration of this. Now, the next thing is that we have to simplify it and say that we have integral of x cubed divided by x is the same thing, then minus 3x squared divided by x plus 2x divided by x, then plus 5 divided by x, then everything dx. So from here I have the integral of x here 1, this one gives me 2, here 1, here cancel here. So I have x raised to the power of 2 minus 3x plus 2, then plus 5 over x, then everything dx. So I can integrate everything together, and I will have x raised to power 2 plus 1, then over 2 plus 1, minus 3x raised to power 1 plus 1 over 1 plus 1. Then if you integrate constants, you have 2x. Then plus this one is 5, then multiply by 1 over x. So don't forget. So you just write what? If you integrate 1 over x, you have 5 ln x. Then everything plus c. So I have x cubed over 3 minus 3x squared over 2, then plus 2x, then plus what? 5 ln x plus c. That is the answer for that one. Now, back to number 2. The integral of minus 4x minus cos x plus 2x dx. So it gives me, let me do it this way. I can say that this is the integral of minus cos x dx, then plus the integral of 2x dx. I can apply it to the first example as well. So I'm now saying I have the minus integral cos x dx, then plus the integral of 2x dx. So from here I'll have minus, what is the integral of cos x? The integral of cos x is sine x. So we write that sine x, then plus, this is 2x. If you integrate 2x, you have 2 multiplied by x. The exponent of xa is 1. So 1 plus 1 divided by the whole of new exponent, which is 1 plus 1. So 1 plus 1, then plus c. So I have minus sine x plus 2 multiplied by x raised to power 2 divided by 2, then plus c. So the answer is minus sine x, 2 cancel 2, plus x squared plus c. Here is where we are going to stop today. So in the next class, I'm going to give you another beautiful integration, method of solving integration, and so on. So till I see you in the next class, thank you, bye-bye.